Okay, so again, understanding the basic derivatives here. Once you understand the basic derivatives, then all you need to do is the same thing, e to the u, du, dx. All right, and this is what gives us our derivatives. So our assignment for today is to find the derivatives of these problems. All right, so if you know the basic derivative, then you can use the chain rule in order to compute what you have. All right, anybody have a question about getting started? All righty, I'll let you keep working for a minute and then we will see how you guys are. Okay. Give you a few more minutes. Anybody at least halfway done? If you're halfway done, please type in the chat. You can only type it to me. You don't have to type it to everybody. Just give me an idea, typing in the chat, which number you're on. There are 11 problems and they go down. So give me an idea by typing in the chat what number you are on. And my chat is empty. Nobody has given me, oh, got 1, 2, good. All right, number 4, number 6. Oh, thank you, yay. I appreciate the response. Okay, so most people are somewhere around 4 or 5. Okay, awesome, awesome. Some people are not quite that far, that's okay. All right. Okay, so I need some help going over the first 5.
Can I do number 1?
I could do the first one.
Okay, so Rodney's going to do number 1. Who's going to do number 2?
I can.
Okay, Ezekiel's going to do number 2. All righty. All right, so we got the first, we got 1 and 2. All right. All right, Rodney, you're doing number 1. Let's go.
All right, so I got the derivative to be 2 over x ln 3.
Okay, so you got your derivative y prime to be 2 over x ln 3. Okay. Anything else?
No, that's it.
Okay, so where did the 2 come from?
Oh, in the beginning, in the front.
Okay, so that should, you got to recopy that, remember?
Oh yeah, I'm sorry.
No problem. You probably have it on your paper. Just forgot to say it. Okay, so again, the derivative of 2 to the u is 2 to the u, and then you have to multiply by what u is. And the derivative, so now we got to remember here, the derivative with respect to x of log base 3 of x. Whoops. That is where Rodney got 1 over x log 3. Awesome. Okay, that was fantastic. Nice, quick, and easy. All right, Anybody have a question about that? If you do, please ask now. Because Rodney smoked that one. Okay, number 2.
I have a
Ezekiel.
question.
Oh, go ahead. What's your question, Annalise?
I thought it was supposed to be multiplied by the natural log of 2, since 2 would be a. Or am I confusing that?
We're missing that term. You are correct. Okay, you are right. We are missing that term. Okay. All right, so what we have is, and this is why I have to write it out, the derivative with respect to x of 2 to the u. So that becomes 2 to the u natural log of 2 du dx. So you are correct, my dear. We are missing a natural log of 2. So therefore, let me rewrite this answer. So in the numerator, it should be 2 to the log base 3 of x, but we have to multiply by the natural log of 2, and then multiply by du dx, which is 1 over x log 3. So this is correct. Thank you, Annalise. We missed
Hey, Dr.
that.
Locke.
Yes,
And this is only if we have the base as numerals, right?
if the base is a number, exactly. So when the base is a number, you have the derivative with respect to x of a to the x is a to the x natural log a, and the derivative with respect to x of a to the u is a to the u natural log a, but then we got to throw in du dx. So you are correct. Here in this problem, a is 2. So a is 2 for that, but in this part, so for this part here, for the whole problem, a is 2. But for the mini problem here, a is 3. So that's why you end up with x log 3. Okay. Ezekiel.
Yes.
All right, we're doing number 2. Oh, where is it? Okay, so here's number 2.
Okay.
I
So-
like 2.
all right.
Okay, go ahead.
Okay. So first, I took the derivative of e to the x to the third.
Okay,
I found to be e to the x to the third times 3x squared.
good. Where did 3x squared come from?
It came from the exponent of e, because x to the third comes out as the derivative as 3x squared.
Perfect. And then your next piece.
And then plus the derivative of natural log of x to the third, which found to be 3 over x.
Okay, so how'd you get it? What'd you start with? What did you put in the denominator first?
The denominator I put
Look at your notes. You had to do 1 over x cubed, right?
yeah. Sorry.
And then you multiply by 3x squared.
Yeah.
Okay, I just want for people that may not have followed what you did, I'm just trying to give them a little bit of the steps. Do you understand?
Okay, yeah, I'm sorry.
Okay, so, yep. All right, so then this is 3x squared e to the x cubed. Whoa, that doesn't belong down there. Move that. E to the x cubed And then, as you said, plus 3 over x. Excellent, excellent, excellent. Okay. Who's going to do number 3? We're smoking through these, guys. Who's doing number 3?
I can do number 3.
Okay, thank you, Victor. All right, so what are you going to do?
Yeah, you'll take the for a natural log within with parentheses, you'll take 1 over the either the square root of x squared plus 2, or you can do the
Oh, whoa, 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 you're doing problem 4.
for sorry.
Yeah.
Oh, sorry. Problem 3. Okay, sorry. For you'll take the natural log of or first it'll be in the denominator would be 3x to the third or cubed plus 2x squared plus 1. And since we're using u substitution, you would take then the derivative within the parentheses, which would be 9x squared plus 4x.
Okay. So you get 9x squared plus 4x divided by 3x cubed 2x squared plus 1. Awesome. Okay, thank you, Victor. All right, who wants to tackle number 4? Number 4 is a beast. Okay, it's not too many things I call a beast, but number 4 is a beast. COVID is a beast.
Can I ask you a question about number 3?
Absolutely.
So couldn't you distribute the ln to each of the things inside and do it like
Oh, that's scary. Okay, I'm gonna write that in red. Remember the log, oh, I'm writing it in red. The log of A times B is the log of A plus the log of B. We do not have a rule for the log of A plus B. There's nothing I can do with that,
okay.
okay? So, yep, we can only use the first rule. The second one, I cannot simplify, and I see a lot of people do that on the test, but you cannot simplify that. You can only do it if they're multiplied.
Okay, thank you.
Mm-hmm. Who's doing number 4?
I can try it.
Okay, Annalise. Are you
So
going? Go ahead.
I would first rewrite it as being the natural log of x squared plus 2 to the 1/2. From there, I would take the derivative, which would be 1 divided by x squared.
Okay, let's do one more step before you do that.
Okay.
Let's do the power rule.
Okay.
So what can you do with that 1/2 in the power rule?
I can move it to the in front of the natural log.
Mm-hmm. That's gonna make my derivative so much easier. Okay, so she simplified first. Yay.
Okay, so then it'd be 1 divided by x squared plus 2.
Okay, so y prime
Mhm.
would be 1 over x squared plus 2.
And then it'd be multiplied by 2x.
Okay, so there's only one thing you forgot,
I forgot to multiply by the 1/2.
by the 1/2 in the front. Awesome. Okay, can you simplify that for me now?
Yeah, the 2x multiplied by the 1/2 would equal just x, so that would go to the top and it'd be x divided by x squared plus 2.
All right, So what she did was she took a beast of a problem and simplified it first and made it a mouse. It started off as a beast. If you try to take the derivative of it in the original form, then you're going to have to take the derivative of the derivative of x squared plus 2 to the 1/2 power. That's not cute. But she simplified first. So once she simplified, she tamed the beast and made it something really nice. Then to take the derivative of it was very easy. Thank you. Thank you.
Problem.
We are smoking through these, man. All right. Next one, number 5. Who wants to handle number 5? Hello. You guys have been volunteering like really awesome. Number 5.
I could do it.
Okay, Johnny.
So it'd be first it'd be 3x squared
3x squared.
minus
Okay.
3x to the ln3
Not to the ln3, but times it.
times ln3.
Are you done?
Yes.
You're done. Okay, you're done. All right, so for the first part was easy, 3x squared. And the second part, the derivative of a to the x is a to the x natural log 3. Okay, number 6 is also rather difficult, but it's doable. It's going to require a product rule and a chain rule. And let's say, let's go with Aaron. Aaron, are you on?
Yes.
Okay. All right, so we're going to do this problem and we're going to do it the product rule, okay?
Okay.
So now with the product rule, you have 2 functions. The first one, let me put a dot there just so our brain can handle the fact that we have 2 functions. The first one is x and the second one is log base 4 of x squared. So how do you use the product rule?
So take the derivative of x and multiply it by log base for x squared,
Okay.
and then add
The
x
derivative of
in,
x is just 1. Right, so
yes,
write the whole thing out. Derivative of x times log base 4 of x squared plus, what we're going to do next?
plus x into the derivative of log base for x squared.
Okay, so first and foremost, if you are ever thoroughly confused on a problem, write it just the way Aaron did, because that simplifies your thinking to see that now I only have 2 derivatives to find. The first one is easy. The derivative of x is just 1. So only thing I need to focus on is finding the derivative of the second piece. Okay, so let's find the derivative of the second piece. So we get the derivative with respect to x of log base 4 of x squared. So how do we tackle that, Aaron?
Is it 1 over natural log of x squared into the derivative of x squared?
Okay, we're close. We're close. So let me write something on the side and see if this helps you, because that was pretty good. The derivative with respect to x the log base 4 of u is 1 over u natural log of 4 times the derivative of u. So I think you kind of got it. So this now becomes the x squared is my u for this piece. So this becomes x squared natural log of 4. And then in the numerator, I have to multiply by the derivative of x squared, which is 2x. Okay, are you with me?
Yes.
Good. Okay, can you tie this up with a bow for me?
So it would be log base 4x squared plus 2x over x squared natural log of 4
Times,
times
you still have an
2x.
front. You have an x out front. You got this guy.
Yeah,
Okay. So that guy gives me
times x.
2x squared over x squared natural log 4. Okay, it's not quite a bow on it yet. Simplify it. Aaron,
Yes.
okay, can you simplify it, please?
So it would be 2 over natural log of 4
Okay,
times
times,
log base 4x squared.
I think you mean plus, but I got you. Okay, any questions? All right, y'all are rocking it out here.
Where did the x go? Oh, wait. Never mind. Never mind.
You got it? You see it?
Yeah.
Okay. All right, 5 more problems. I guarantee you, you're going to see at least 2 of these again. They may have a different base, but you're going to see at least 2 of these again. Okay, so let's go with number 7. Number 6, wait a minute. What was the last one we did? 6. Okay, so this would be number 7. All righty, who wants to handle number 7?
Oh, wait. Actually, I do have a question because I can't see it on the previous
Okay,
problem.
no problem. Let me move it up. All righty. Oops, I moved it up too much. There we go.
So for the 2x divided by x squared natural log of 4, wouldn't it be 2x squared? So you take out the x squared because in the problem above, it's x times the derivative of log base 4 x squared.
So that's what happens. So this term, the 2x over x squared natural log 4 multiplies by the x and gives you 2x squared.
Oh, okay. Okay, yeah. I just saw the top, I didn't see the bottom.
No problem. And then the x squared divides with the x squared, and you have a nice simplified, cute little problem. That's kind of cute. It's all nice and precise. Okay. Number 7. Anybody want to volunteer before I snag somebody?
I'll try it. It looks hard.
Okay, who is that?
It's Johnny.
Okay, Johnny, let's see if we can give somebody else a chance to try. I know, that's frustrating.
Can I try?
Who's that?
Victor.
Okay, Victor. What do you want to
Um,
You already had one.
do? I knew it was coming. I knew it was coming. But I think you already did too, Jai. I knew it was coming. I knew you were gonna say Victor already did one. Okay, all right, we'll let Johnny do another one, but Victor's gonna do this one. Okay, go ahead, Victor. I promise you, Johnny, you're gonna get one before the end. Okay, go ahead, Victor.
um, this is the or first you have the inverse of the tangent inverse would be 1 over 1 plus x squared, and then you use substitution.
All right, so you're starting with the fact that you know that the derivative with respect to x of the tan inverse of x is 1 over 1 plus x squared. Oh my God, y'all are hilarious. I am loving this class. Okay, so you have using that. So now you got to change that to u, right?
Yes.
Okay, so now you're going to use the fact that the derivative with respect to x of the tan inverse of u, you're now going to do 1 over 1 plus u squared, but what are you going to multiply by?
Sorry, you take the square root of x squared plus 1, but but first you have to multiply by its derivative, in which you can make it to where the x squared plus 1 to the power of 1/2, and then you
Okay.
take.
So your u is x squared plus 1 to the power of 1/2. Okay, so what is du?
Du would be 1. Oh, technically it would be x x to the power of well, negative 1/2, or x squared plus.
Okay, good. But did you bring the 1/2 down?
Yeah, so I was thinking because of the exponent from x squared. That's what I was.
Okay, and then you still have to multiply by the derivative of the inside. Go inside. What do you pull out?
You pull out 2x.
Good. Okay, so what does this derivative become?
It becomes 2 become x times x squared plus 1 to the power of negative 1/2.
Okay. All right, so now we got to put this monster all together. You ready?
Yeah. And so you take so the derivative of that value would be or it'd be x x times x squared plus 1 to the power of negative 1/2 over
Okay.
1 or 1 plus the tangent, or you can say tangent inverse of, or it'd be 1 over the square root of x squared plus 1.
Say that last word for me.
I'm sorry, it'll be that's a tangent inverse
You
of
said 1 over the square root of x squared
oh,
plus,
sorry.
and I said, say one more word for me and you're done.
Oh, wait.
You got it. U has to be squared.
Yeah.
Yeah, this is u. That was u. This is u. So that has to be squared. So this becomes x over, and you don't have to write it like this, but this is the way it would be. So this is going to be 2 plus x squared, because x squared plus 1 squared is just square root of x squared plus 1 squared is just x squared plus 1. Add 1, that gives you 2. So I get that. And then I still have x squared plus 1 to the 1/2 power. That came from the numerator down to the bottom. Okay, yep, that was a beast. All right, Johnny, you want to do the next one?
No, can I do it?
Yes, I'll let you do it.
Well, I'm sorry, I didn't mean to say no, like Johnny couldn't do it, but I will. Okay.
Y'all, it's enough to go around. I'm going to keep these problems coming. All right.
So
let's
for the
see.
next one, I gotta solve it out or say the answer.
Yep.
Okay. So what I did was
What's your U? Start there.
1 over E. I mean 1 over X E.
Good. 1 over X is my U. Okay.
I'm trying to scroll down. I can see you writing. Oh, you writing right there. Okay.
I just wrote 1 over X.
Then I did 1 over X and plus E.
How'd you get plus E?
Not plus E. Maybe I did this wrong.
Okay, keep talking.
Yeah, I don't know what I did. That's
Okay, well, we're going to fix it. Find the derivative of U for me. So U, well, you can write U as X to the minus 1. So find the derivative of U for me. How do you take the derivative of X to the minus 1? Come back, Ayana.
my goodness. I'm sorry. I do not
Okay.
know.
We're going to help you. Don't worry, we're going to help you.
This
I
embarrassing.
appreciate you wanting to volunteer. So now we're going to help you. All right, so if U is X to the minus 1, then the derivative of U with respect to X says bring the minus 1 down and multiply by X to the negative 2. Just bring it down and subtract 1 from the exponent, right? Okay. So this now becomes negative 1 over X squared. We good?
Yeah.
Okay. So now this is E to the U. So Y is equal to E to the U. So then what's its derivative? Its derivative is E to the U.
Oh, so E to the negative 1 over X squared.
Okay, wait. That's the du dx. Remember, E to the U, but because it's U, I have to multiply by du dx. So therefore, I get Y prime is E to the U, which is E to the 1 over X. And then I have to multiply by negative 1 over X squared. So my answer is Y prime is negative E to the 1 over X. And then the whole thing is divided by X squared. Again, that was a beast, but we talked through it. Ayana, does that feel a little bit better?
Yeah, I don't know what I did because I didn't get that, but okay.
Okay, so we just need
I
to.
just was like, let me answer before she called on me before for one that's real hard. It kind of looked easy, but I guess not.
You're so funny, but that's okay. We got through it, right?
Yeah.
Okay. All right. We got 5 minutes. So Johnny, you want to do 9 or 10?
I'll try 10.
Okay, because 9 is just like the other one. So let's try 10. We'll do 10. All right.
Would that be the quotient rule?
Yes, sir. Okay, so number 10, how do we do this? So Y prime.
Also, it'd be X times.
What's the quotient rule?
Is it
It's
what? Low, high?
Yeah, low D high.
Low D high, high D low.
Low D high minus high D low over low or over low squared. Okay, so what do we do? What's low?
It would be the x times 1 x times the derivative of 1 minus e.
Okay, so
2x.
you're going backwards.
Going backwards.
This is low. And this is high.
Okay. So it'd be 1 minus e to the 2x times
Times.
1
Good. Times 1.
minus x,
Mm-hmm.
and then derivative would be 1 minus,
What's the derivative of 1?
that's 0.
Okay.
So it'd be negative e to the 2x times 2x.
Times what?
Times 2x,
Times what?
2.
2. Good. Okay, all over
1 minus e 2x squared.
All right, simplify that.
So the 1 minus e 2x cancels out on top.
You can't cancel
Oh,
because every term doesn't have a 1 minus e to the 2x. So I can't cancel. I just have to distribute.
okay. So it would just be 1 minus e to 2x minus x. Oh, it'd be plus x. Wait, plus ex. Yeah, plus x e 2x times 2 times 2x.
All righty.
Negative 2x.
Good. We leave that, we don't multiply that out.
Okay.
Okay. So that's it. The minus the negative makes it positive. We got a 2 and an x gives you 2x. We get e to the minus 2x at the top. And then there's 1 minus that. That's correct. Any questions about that? Okay. I will send you a full sheet with the answers on it. And so you guys can look over it. We only have 2 problems we didn't do. So we did pretty good. All right, any questions? All righty, I will see you tomorrow.
Hey, Professor.
Yes.
Yeah, this is Chuck. I didn't get marked for attendance.
Yes, because I called your name 3 times.